So yeah, I've been reading this book. It's got some things that are really inspiring for me. So I want to share those things, a few examples of the things.
Okay.
So one of them was the subway map example, where this guy made an improved subway map for New York City. The beginning, he uses the London subway map as one of his inspirations.
Okay.
And that, unfortunately, I didn't find this online, but this is like an older version of the London subway map.
Okay.
It looks like very clean, and the colors are very nicely contrasted with each other.
That is true.
Uh, and just like very clean, very not very busy looking. I just like the concept of, you know, just like that there is a way to put a lot of information on the screen and still have it be useful and still have it be clean somewhat. What do you think?
I guess there probably is a difference between like a paper map, like a map that you have to display in a limited amount of space versus like a screen that could be like infinite or you can zoom in, zoom out.
Oh wait, am I not sharing my screen?
No, you are not.
Oops. Yeah, this is the version of the New York map that this author, it's Eddie Jabor, and so this is his map. And then you zoom out, it looks like this. Yeah, what do you think about this map?
Well, I think I can find the information that I need if I'm familiar with how subway works, but it's definitely a lot of information.
Mm-hmm.
And also, I feel like the other thing is if I were like a user of a mobile app, maybe I will rely on, say, I just put in where I want to go, and then it will just tell me how to go.
Right.
So I need to look at this map.
That's kind of true. Yeah, if you
Because
think about how Google Maps works,
yeah, there will be algorithm to just tell me what I should do, like get on in here and then get off there.
that's true. And then it'll just line it up as just one line.
Exactly.
And then you
So
would follow that one line.
so you don't care about all these other information on this map. It's like how things like overlapping with each other and how what's the direction and all this stuff. But it's kind of cool because you don't have those information when you just use the app, but you do have the information when you look at the map.
Yeah, what you bring up is an interesting point in that when you have a very specific goal, then you only care about the information that's relevant to that specific goal.
Right.
And so if you think about if you're debugging a problem, you have a specific problem, and yeah, whatever the program can do to help you narrow down and filter out the noise, that's probably desirable. Other than the very specific goal, however, I would argue that there's a secondary goal of these user interfaces, not just help you accomplish that one goal. The secondary goal is, over the long run, we would actually like to educate you on how the whole system works.
Right.
And I guess you don't really advertise that goal necessarily, but that's something that happens gradually as you're using the tool to do the specific goals, right? To accomplish the specific goals. Over time, you'll just learn how the system works as a whole.
Yeah, what if your goal is just to learn how the system works? It's like if you get a new piece of code that you never seen before, and you probably want to know how it works from a higher level first, but the author telling you, how can you know? I think that is a good way. It's a good goal just by itself, I guess.
Yeah, it's a good goal by itself. Usually what happens, at least currently, is usually like the person just is given the task to do. I'm thinking about software projects, obviously, but usually the person is just given the task to do, and his goal is to do the task. And sometimes the task is can be accomplished with just very narrow information, but sometimes it needs a larger scope of information. It depends on the task, right? Like sometimes all you need is to go very local. Like all you need to do is zoom all the way in and then do something very locally, and then you're done. But other times you actually need to bring together several pieces at a higher level. And I guess the problem is some people may not realize that's the case, maybe, or they they try really hard to stay local, um, and because it's too overwhelming for them to learn more pieces, maybe.
Well, if everything is perfectly modularized, it's okay to stay local, right? I mean, that is a good situation for, say you have a large team and everybody just work on a small piece. You don't have to care about the local, and only small amount of people needs to care about how the whole system works.
No, but sometimes a feature requires adding features to multiple modules.
That is true.
And then you have to handshake between the modules.
That is true.
Yeah, and also often they're not perfectly modularized, so you have to like rethink what is a better way. A lot of times.
That is true.
But yeah, but I think that's interesting. Like both of the things, I think you want to keep in mind that yeah, I want to make it really easy for them to isolate for the specific goal they're working on, but also at the same time, we like for them to be able to like see the surroundings and see how everything is fitting together. It's similar to the library. An analogy in the library is a lot of times when I go to the library and the librarians are like teaching me a lesson or something, they will emphasize the ease of browsing in the library is very desirable for, or they think it's a very big value add. And the fact that you don't have the ability to browse when you're using a search engine, that's what the library gives you. Is when you're walking around the library, you just naturally see the books around you.
That is true. Yeah, I think this is an issue with the current people's way to receive data, because how the search works and how like even like AIs, they will direct you towards things that you are looking for. So you don't see the other things that you are not looking for, or you don't know you should be looking for. So I feel like currently it's very hard for people to see the bigger picture, just because how people get information is by using search engines.
It's true. It's true. Like the people who end up being really good at this, they are the people who can actually see the big picture in their head. Yeah. So you basically need to have both, I think. And maybe what we can do better is to help people see the big picture as a whole without, without forcing them to have to do it themselves in their own head.
That is true.
Okay, so this is one example of a visualization that I really like. Oh, and then I thought about, well, what is something that is comparable to this? One idea I came up with was a flowchart. So there's a tool. Last time we talked about reverse engineering. There's this reverse engineering tool that will actually read your binary executable code.
Okay.
read the assembly language from it and look at the jump instructions to try to piece together this flowchart of your program.
Uh-huh.
So I did that for.
Yeah, I always have a problem of understanding how flowchart work. This flowchart like, okay, in here you have yes or no or this or that or different branch, and then you go to different states.
Yeah. So this is if false, then go to this box. If true, the green line is the true, and there's a little T over here. If true, then go to this box. And this picture is so large that I had to shrink the text to very small. And then even then I had to do 4 screenshots and stitch them together to get this picture.
Okay.
So now I have something that's kind of nice that I can zoom in and out. And you can zoom, if you zoom in, you can still see the text. This code is 1,590 lines, but the part of that the flowchart is visualizing is only this one main method. The main function, I should say. These are not methods. This is a function, which is just that part. And I guess the reason why it's so large is every single if statement that I have is going to end up being one of these branches. So and also, so I have several if statements that are kind of like, a lot of them are early return statements. So you can kind of see all the early returns are guard clauses, and they're like, well, if this, then jump all the way to the end, and it jumps all the way to the end. So all of these blue lines over here, they represent guard clauses that are gonna prematurely jump to the end. Well, anyway, this is one idea that I thought of that might look similar to a subway map, maybe.
Okay, so here is the question: Is it easier to look at the code, or is it easier to look at this flow chart?
Yeah, obviously it's obviously it's easier to look at the code right now because we're trained to look at the code. We as developers, we don't look at the flowcharts.
Yeah.
As we code, but that could just be a force of habit kind of thing. So I don't know. I don't know in what situation. It feels like when you're trying to reverse engineer a program that you know nothing about. I imagine this definitely helps.
That is true.
But when you're writing your own code, you're just not accustomed to looking at it this way. So I'm not sure.
This reminds me of the child's coding language. Is it?
Oh yeah. There's Scratch. Yeah, so you've seen this kind of stuff where if I create a loop, I go to the control section and I say repeat 10 times, move 10 steps, and then maybe if sensing, if I'm touching the mouse pointer, I don't know, maybe turn out, I'll turn 15 degrees or something. Yeah. They don't exactly render it as a flow chart, but they render it like a diagram at least. This is pretty good. Yeah. In college, I was at one point I got kind of excited about visual programming like this. I went to my professor and I said maybe I should make a visual programming language that uses GCC, the C compiler, to compile. And and then my professor said that's a waste of time. So this is a second example that I want to show you. This is flight path data. Is a visualization of all of the flights in that occurred in North America.
Okay.
We'll just watch it. It's short, relatively.
Oh, it's a time thing. It's like
it's an animation.
He does what?
This part is interesting. Like I think it's like the morning. So it starts from the East Coast. Did you see that?
Yeah.
It kind of like everybody's sleeping, and then it's almost like the sun is rising, and it's moving across the United States.
That is true.
So I like this. I mean, it's just kind of beautiful to look at this visualization. And I guess I thought like what would be something like when you're visualizing code, what it would be something that could look that way. I thought of this flow chart. So maybe like as the code is executing, it looks like these lines that are moving. It looks like these particles are moving along these lines, maybe.
Uh-huh.
And at a large enough scale, maybe that can show you some sort of pattern. Although it's probably not. It's probably better for educational purposes than it is practical. Maybe you just see the line moving over time, like that, and then if there's a loop, so you would see like a beam of light that's going through here and then over here going back to the top. So it's making a loop like that.
We'll identify infinite loop very easily.
so the only problem is it's an animation, so that means it's going to be slow, right? And if you have a lot of code execution, you're sitting there for a long time looking at the animation.
Well, to me, this kind of animation, it's more for like, I don't know, it's more for like maybe seeing the big picture, like seeing, because it's like just looking at the flight thing, like you can see, hey, the East Coast started first and then it goes to West Coast, and then you can see the trend of that. But it's not like, do you think it's helpful to solve the individual problem that you have? I feel like that's more of a big picture kind of data.
Yeah, there's there it could potentially be useful for isolating performance problems, maybe. Because or memory leaks, maybe, because the performance problem requires you to look at the big picture. Like you're trying to say, okay, this is the total time taken. I need to kind of break it down into subsections, but I need to know the percentages so that I can allocate effort, but decide which part is more worth the time to optimize. So if you see a ray of light that's spinning at a particular area a lot of times, then you might say, oh, it's spinning over there a lot of times. I don't know. I don't know. I kind of think we might need to see it for real programs before we know if it's useful or not. Or maybe another idea might be like, although I had a harder time coming up with how to map the XY coordinates for this example. The other example I had was if you plot the lifetime of all the objects that were allocated in the program, if you had like one object create, maybe if our time axis was here, then it would not even be an animation. It would just be the lifetime of the object started here. Maybe it mutated over here, and then here it died. And then another object here, and then it died. And then maybe we just have a lot of lines, maybe. Can we use like an animation to look at something like this? Maybe like an object is a dot or something. And maybe some objects are larger because they take up more memory. and some objects are smaller, and then we play an animation over this, and then some of them will grow bigger in size maybe,
Mm-hmm.
and
Oh, that's an interesting one.
and then shrink. And then there would be at the beginning maybe there's very few objects, and then all of a sudden there's tons of objects, and then maybe at the end a lot of the objects die back down. I don't know.
It's good for testing memory leaks.
Yeah, that might be good for testing memory leaks, but there's no like moving in terms of location of the objects. How would you say? Maybe like if maybe the objects start over here and then they gradually move over here, and then when they're over here they die. I don't know.
Okay.
But then they would, yeah, like this is moving over here. So like in the animation, it's like gradually going there. So you have one that's over here, and then on the next frame, it's like that. and then there's more that are coming in here or something. I don't know. There's some ideas.
Pretty interesting.